Welcome back, friends and neighbors. It is now time for the answer to Packet of the Week number 26. Well, here was the hex for that particular packet without any indications as to what's going on, although when I did the packet, of course, I highlighted layer 2. So here's just a little more detail about layer 2. The first 12 bytes of this blue portion should be pretty straightforward, right? That's the two MAC addresses, the destination and the source. And then the one part that's in the box there, that is just what we call the control field, or in this case, it's a protocol ID. It tells you what this Ethernet frame is carrying. And in this case, the hexadecimal value 0800 means that this particular Ethernet frame is carrying an IP version 4 packet. And I put that arrow on there to indicate the start of the IP version 4 packet, but the first number in this first byte of the IP header is a 4. And that indicates that it is IP version 4, and the 5 there is the number of 4-byte words. So if we go 5 times 4, that is a 20-byte IP version 4 header. And here's the rest of the IP version 4 header. It's pretty straightforward. I'm not going to spend a lot of time here. I will point out a couple of things to you, that if you decode the hexadecimal, the last two fields in this are the source and destination IP addresses. And so if you decode those, starting at the C0 there, that I've just circled one of the IP addresses, we can see that this is 192.168.15.201 going to an address on the 10net. So that should be pretty straightforward. And in fact, if you do this a lot, you'll recognize C0 as a 192. Now, the only other thing that I've highlighted here, because there's nothing really special in the IP header, is that I've circled that number 11 there. But of course, that's hexadecimal. So that means that it's 17 in base 10. And 17 in base 10 means that the IP header indicating that the IP packet is carrying a UDP datagram of some kind. And so this is how you begin to decode this, right? So we learned from Ethernet that we're carrying IP version 4, and we learned from IP version 4 that we're carrying UDP. And hey, there's our UDP. Now, if you remember, UDP is a fairly straightforward header. It's only 8 bytes with a source and destination port number, and then we've got some error checking, and then a length. And so what I've highlighted here is the destination port number, and this happens to be A1 in hexadecimal. It's a 2-byte field, but the A1 is the only thing that we've got that indicates what's happening here. And A1 is 10 times 16 plus 1 times 16 to the 0, which gives us 161 altogether. And so that is the port number that we're using here. And if you're keeping track of what your port numbers are used for, you know that that is SNMP, which brings us up to layer 5 in the TCP/IP model, where starts our transition into application data if you're talking about the OSI model. And, well, let's see here. Everything in red is the SNMP stuff. Now, SNMP, if you're trying to decode this, SNMP is one of a crazy set of RFCs. I mean, there are a lot of them. This one happens to be an SNMP version 1 packet, and we get that from the Wireshark dissector. But it's almost difficult to tell that. That's the highlighted or the yellow circle there that indicates that it's a 0 means version 1. But we've got all this extra stuff in there because of the structure around SNMP. Now, I don't want to turn this into a lecture on SNMP. I'll give you a couple of links later on to help you try to understand this. But there are a couple of details here that are worth going over. One is that this is a GET request, and a GET request makes a query. It is a query to a node that has an SNMP agent running on it. So the network management system makes an SNMP query, and it asks for some piece of information or a collection of pieces of information, and uses what's called an OID to make this request. Okay, so in this particular packet, there are several of those requests happening. The other thing that's interesting here is I've got sort of a yellow rectangle around another string of hexadecimal characters, and string is the key word here, that actually happens to be a community string. And the way that SNMP objects, or the way that SNMP elements know that it's okay to talk to each other, is with this community string that's out there. So the numbers beginning with 70 and then ending in A0, that's, or I'm sorry, 63, that's actually the public, in this case actually says public, community string. Now there's a wrapper around each one of the requests. So I've just highlighted an example of the OIDs that we're using. So the green box starting at 06 and then going all the way to 0550, that is a request for a particular OID. But the OID actually starts at 2B and ends at 01. So this is a collection of fields together that are wrapped around each OID request. Okay, so what's an OID? Well, an OID is a specific reference to an object or piece of information on a device, and it has a very particular structure. And the example from the RFC is in the bottom right-hand corner of this particular packet. So that's right out of the RFC, and that's just an example of how it's organized. And the way that you think about this is that you say, all right, well, if I was going to ask a device for something, how would I be able to ask a device for something and then take a device from, say, a different vendor and ask for the exact same thing? And the way that this works is they all implement something called a MIB, a Management Information Base. And every object in the MIB is referenced by these OIDs. And the OIDs drill down through the organization that created the standards to the type of device and finally the element to give you a very particular item that you can ask for. Now this is a MIB structure. It's also called a tree. And this shows you from top down how you would drill down one step at a time to get all the way to a very specific item. And so you got the organizations all the way at the top, and then the type of devices and the type of protocols, and all the way down to something very, very specific at the bottom of the tree. Now the idea is that if you string this series of numbers together, you wind up with a very specific request or a very specific item that you're pointing to. All right, so what was this one? Well, for a little more detail on, first of all, any protocol that's out there, you can go out to our friends at Wireshark, and they've got this fabulous wiki out there that you can look up protocols on. You can also, of course, use everybody's favorite Wikipedia or Google. But if you want to see some very technical details and a list of RFCs and things like that, you can always go out to Wireshark. So there's a collection of things within SNMP that are put together. So we've talked about the MIB. We've talked about these requests that you can make from a network management system to nodes that have an agent on them. Those nodes can also send things back to the network management system via something that's called a trap. And a trap is sort of an event. This thing occurred and the device wants to tell the management system or the server about what happened. All right, so there's a very handy tool out there on the web called at OID Info. It's actually a lookup tool that you can use to discover something about an OID that you happen to be looking at. Now, usually if it's vendor specific, it won't be out there. The vendors themselves should post those. But every standardized device has, as part of the standard or as part of a published MIB, all of the things that are able to be queried via SNMP. In this particular case, the very first of the OIDs that was in this packet was 1.3.6.1.2.1.25.3.2.1.5.1. And here I've just used the lookup tool to indicate what this actually means. And so this is actually a status request for a very particular item. And I think in this case I was talking to a printer. So it's ISO, and then we had an identified organization, DoD Internet. Internet is a set of protocols and standards that came out of DoD research. Management, that makes sense. We're talking about SNMP, MIB, host device, device table, device entry, and then the status of this particular device. So there you go. That's how you would drill down. And if I asked any other device of the same type, it would know what I was asking for because I sent that. And just for fun, here is the original packet. that put all this together. So if you decoded this in this fashion and got most of this stuff right, then hey, kudos. You are well on your way to understanding the content of packets and how to decode them. This, by the way, is exactly how a Wireshark dissector works. It goes protocol by protocol, looks in there, and at every layer, we have some hint that tells us what's going to be next. Well, thanks for watching. Thanks for listening. I have no idea what videos we're going to do next. If you got any ideas or things you want me to cover, I'd be happy to do that. I've been building a lot of stuff in the lab, so I haven't been putting out as many videos. But hey, give me some ideas, or if I come across something that's fun to build, I'll post some videos for it. Thanks again, and may your packets always reach their destinations.